Hello and welcome. I'm Dave. Today we will learn about Lambda and higher order functions in Python. And I'll provide links to all resources in the description below. I've got VS Code open, a new folder for lesson 17, and let's create a new file and let's name it lambda.py. Okay, we have two topics today, and we're going to start with lambda functions. A lambda function is a single expression that returns a value. So let's look at a simple example. And we start with the keyword lambda. So LAM, and then you see BDA, and I'll just press tab, and there it is. And Visual Studio Code highlights it because it's a keyword. And now we're going to pass a param. So I'll say num. Then I'll put a colon, and I'm going to say num times num. So this function would square a number. So if we pass 2, it would be 2 times 2. And this is a single expression that will return that value. But notice we're not using the return keyword, but it will return the value. Now we can't call this function into action by name because it's anonymous, and sometimes lambda functions are referred to as anonymous functions, but we can assign a lambda to a variable. So now I'll just take a variable name over here and I'll say squared equals, and now it's going to store that function in the variable name squared. So let's go ahead and use the function as an example, and I'm going to need to print the output. So I'll say print and then say squared, and I'll pass in 2 like the example I gave. Now let's go ahead and choose this drop down here, and I'm going to run the Python file, and we'll see over here on the right, we get the number 4 as the output. Now just to understand the concept, let's make another one, but I'm going to press Control B to hide the file tree so we can see all of our code here, and we can still have our terminal over here on the right. We could even type clear to get some extra space and clear that out. So now our second lambda, so let's go, oh, and notice this added the def keyword here as I typed squared there, and it added the return key. So Visual Studio Code formatted that lambda for me, and I didn't catch that until now. But let's go ahead and do the Control Z to undo these changes. Now before I saved it, this is what I had. So squared equals lambda with a num, and that's the keyword lambda, and then we're returning num times num. So that is an expression, but then once I saved it into squared, it went ahead and changed it. So once again, when I save, it changes it to this def squared, and it made it a one-line function essentially. So VS Code's going to do some of that auto formatting, and that's okay, but it's actually the same thing. So now let's go ahead and create another one, and I'll call this add2, and it's going to be equal to a lambda, once again, that has a num, and then we'll say num plus, or plus, I need the plus symbol instead of the multiplication, num plus 2. And then we will print what it puts out, and we'll say add 2, and let's pass in something like 12. Now when I save, it's probably going to reformat this in Visual Studio Code again, so I'll save, and yes, we can see it was reformatted, but let's run the code, and we get 14 over here, which would be 12 plus 2. Now, even though Visual Studio Code is changing this formatting when I save, it's important to know how to write a lambda as I'm writing it with that keyword lambda. So we're going to look at some more examples, and in the future, you'll see why that's important when we get to the second topic, which is higher order functions. But first, let's create one more because I want to show that a lambda can accept more than one parameter. So I might have a function, and I won't set it equal to a variable here. I'll just write the function. So I'll say lambda, and then I'll say A and B. So 2 params here, and then this would be a sum function, so we just say A plus B. So you can see what this would do. This is an expression, a function expression, which is a lambda function that accepts params A and B, and then it returns the sum of those two. Now if we set this equal to sum, of course, then we'll get that reformatting from Visual Studio Code again, but I'm going to go ahead and use sum here, so I'll say print, and I'll say sum, and we'll pass in 2 and 2. Of course, when we save, it reformats it, and you can see it written in a more traditional function way here. And let's go ahead and run the code, and we get 4 once again. And with that being the same as our first function that was squared, I want to show that's different, so let's go ahead and just pass in 2 other numbers like 10 and 8, save, rerun the code, and now you can see we get 18 because it's 10 plus 8. And before moving on, just so I can have this in the source code for you, I want to put the Lambda functions in comments, even though Visual Studio Code reformatted when we save. So let's put a comment here and how we would write this with a Lambda. So I'll say Lambda, and then we had a num param, and then we would say num times num without that keyword of return there and without the keyword def as well. So just our function expression, which is a lambda. So that was our squared function. Now let's move on to the add to function, and we'll write another comment here, which was lambda, and then we'll say num, and then it has num plus 2. And then I'll go ahead and just copy this down and paste under sum as well, so we can write a lambda there. And that has A and B, so we had A and B, and then it was A plus B here. Just so you know what the lambdas look like, and you can refer to that in the course resources. Now let's scroll up for some room, and I think you have a good idea of what lambdas are about and how to create them. I'm going to add a line of comments here just so we know we're moving on to our next section. So the next logical question after you've learned about lambdas is, when would I use one? Well, they're most often used inside of another function, really when you just need a quick function that you don't want to save for later. So let's look at how this works. And it also makes lambdas very powerful when you do this. So I'm going to define a standard function here, and I'm going to call it func builder, which stands for function builder, and it's going to receive one param, which is x. Now inside this function, I'm going to return a lambda function. So I'll say lambda, and then this is going to be num once again, and then we'll say num plus x. Now let's look at how we can use this function to build other functions. So I'll say add 10 equals func builder, and I'm going to pass in 10. And then below that, I'll say add 20, spell 20, there we go, equals func builder, and I'll pass in 20. Now what we have here is the x that we're passing in currently. So we're passing in 10 as x, and then this lambda with add 10 is going to add 10, and then the same for add 20 because x would be equal to 20. But notice the rest isn't defined yet, and we're returning a function. Now you've seen this before. When we used closures, we returned a function and then we called it later. So we haven't called add 10 or add 20 into action yet. So let's go ahead and do that now, and we'll need to do it in a print to see the output. So I'll say add 10, and I'll pass in the number 7. Now I'll copy this down with Shift Alt and the down arrow, and I'll change that 10 to a 20, and we can add 7 to that as well too, so we'll know the difference. Let's go ahead and save and see if we get any formatting that's different, but no, Visual Studio Code left our lambda the way it was inside of a function, so that's good. Let's go ahead and run the code, and now we can see we get 17 and 27. So we're using a lambda as a function builder essentially here in this first function. So the lambda is being returned, and then the lambda is actually called when we call add 10 and add 20. So in our example here, the lambda receives 7 as the num parameter, and it received 10 the first time as the x param in the func builder function. So now we're ready to move on to higher order functions. So I'll put another dividing line in here with our comments. And then let's go ahead and discuss this. What is a higher order function? Well, it's a function that takes one or more functions as arguments, or a function that returns a function as its result. So yes, by that definition, up here we just created a higher order function as well because it returned a function as its result. That's our func builder here. And now we're going to look at some higher order functions that actually accept functions as parameters when we pass those in. So I guess, once again, when we define the function, we define it to accept a function as a param, and then when we actually pass in the function, that function is an argument. And I should also highlight the fact that yes, when we learned about closures, we were returning a function just like func builder, so we also used a higher order function there. But this is where I really like to start to talk about them, and that's when we start passing functions into functions. And that really brings up the discussion of higher order functions for me. Now, these are predefined functions that are built into Python. So we'll just use this function. We won't have to define it. And of course, then we'll be passing in a function as an argument. So let's start by looking at our squared lambda again. So I'm just going to type this out once again. It's lambda, and then we have a num, and then that num is going to be multiplied by itself. So that lambda squares a number when it receives it. So now let's define a numbers list, because we need a collection of data. Now we've learned about different data collections. It wouldn't just have to be a list. We could have tuples and so on, but I'm going to use a list for most examples today. I'll pass in some numbers here, 3, 7, 12, 18, 20, 21. That's good. They wouldn't have to be in order. You could use any numbers you really want to. And then I'm going to say squared numbers, or squared nums. Let's just say squared nums equals, and then we'll call map. Now map is a function that is built into Python, and it receives a function as the first argument. So what I'm going to do is take this lambda right here, use Control X, and just paste it in here with Control V. So that is the first argument. Now the next argument is your data collection. So now we'll pass in numbers, and then it's going to iterate over every item in this list, each number, and it's going to apply that function to it, and then it will create a new list. Well, it won't actually be a list at first. We're going to need to apply the list constructor to it. So I'm going to say print, then I'm going to have list as our list constructor, and then I'll say squared nums right here. So let's go ahead and save this, and we'll run our code and see what we get. So we have a new list here, and notice each number has been squared. So 3 times 3 is 9, 7 times 7 is 49, etc., all the way through the list. So really, that's something we could achieve with a loop, but knowing how to use map is so much more efficient, and your code is so much cleaner. This is just one line of code that we achieve all of that in by passing in a lambda function and passing in our data collection to the function map. Now we're going to look at another built-in function that works much like map, and it is called filter. So we're going to use that same numbers collection up here, and then we're going to filter some results with that. So let's create another lambda. So I'll type lambda, and now this will receive a number as well. And we'll take that number, and then we'll use the modulus. And if you remember the modulus operator, it actually returns the remainder of division. So anytime we divide by 2, there's going to be a remainder if the number is odd. So what we want to say is we're checking to make sure it's not odd, or actually we should say we're checking to make sure that it is odd. That's what I want to do, is return the odd numbers. If it was equal to 0, it would be even. And if it's not equal to 0, as I typed here, it will be odd. So let's think about this lambda. What will it actually return? Well, it's going to return true or false because we're doing a comparison. So it's either equal to 0 or it's not. So it's either true or false. If true, this is an odd number. So now let's define our odd underscore nums, and we'll set this equal to filter. Now we're going to pass in the lambda. So once again, I'll highlight this and Control X to cut, Control V to paste. And then we had our numbers list that I'll pass in here as the second param to filter. We've got one line of code with filter, just like we did map, and I still need to print and then use the list constructor and say odd underscore nums and save. Let's go ahead and find out what is odd and what is not. We actually had our lambda return true or false, and filter, the filter function, then only returned the numbers that got the true result. And so we can see we previously had these numbers, and 12, 18, and 20 were even. So we only have 3, 7, and 21 in our new odd nums list. So now both of these results could be achieved by creating a loop and looping through the numbers and doing the appropriate actions through each iteration of the loop. However, once again, much simpler to have one line of code where you pass in a lambda function and apply it to each item in your data collection that you also pass in to filter, just like we did with map. But map has a different approach than filter. Filter filtered out anything that did not get a true result from the function we passed in. And map returned the result of this function applied to each item in our data collection. We've got one more higher order function I'd like to cover today, so let's scroll up for some room, and then I'll come down here and I'm going to type an import line, but just know that when we save, VS Code is automatically going to take this import line to the top of the file. So we won't see it down here on line 52 anymore, it will be probably on line 1. But we're going to say from functools, import reduce. Now reduce can be a more complex function, but at its most simple, it just adds everything together. So let's look at an example that is simple first. Let's start with our lambda, and the function that reduce accepts needs two parameters. And the first is an accumulator, or you could say a subtotal. The second is the current, which represents the current item. So here we're just going to say take the accumulated total and add it to the current number as reduce iterates through our collection of data. So now we need some numbers, and let's define those here. We'll say numbers equals, and we'll go 1, 2, 3, 4, 5, and back to 1. That should work. Okay, after we have our list of numbers, let's define total and set it equal to reduce. And then we're going to pass in our lambda, so I'll highlight it and say Control X, paste that in as the first param. And after the lambda, we need to pass in the numbers data collection. Now that wrapped down to the next line, but that's okay. It's still basically one line of code. You can see line 58 just got a little deeper here. Okay, so now we've done that, and we're just going to print total. I do not need to use a constructor here. These are all numbers, and they will just be added together. So we'll save this, and you saw the import is now gone. It's probably at the top of the file. Let's go ahead and hit the play button to run, and we get the total of 16, which is the total of all of these numbers. Now, adding all the numbers together is a good example to, a simple example to show how reduce works. However, you don't want to do that when there is a simpler solution, and reduce is kind of a complicated solution. So if I remember right, I named a function sum up here somewhere. Let's find it. There is our sum. Let's call this something else like sum total. So I'll just put a total at the end of this. We'll say sum underscore total would be more accurate for a Python name. So we'll call this sum underscore total just to have it named something different, because there's actually a built-in function named sum. So you don't really want to name them after a built-in function. So now we could just say print, use the built-in function sum, pass in our numbers, which this is very much simpler than using reduce. And if we run this code, we should get the same number, yes, 16 twice. So while we're using reduce, we don't want to use it if there is a simpler solution. But reduce can provide some more complex solutions. One thing you can add here, for example, is a starting number. So a starting value, let's go ahead and put that in, and we'll say 10, and we'll save and run this code again. And now we have 26 and 16. So we told reduce to start with another value. However, we could also do that with sum if I remember correctly. Let's try it out and put in 10 here as well. So we run this, and now we've got 26 twice. So once again, we're not doing anything with reduce that we can't do with sum right now. So sum would be the better solution. However, let's look at a more complex solution for something else we could do with reduce. So I'll scroll for a little bit of room here, and we'll give a second example of reduce. So I'll create a lambda, and this is going to be similar to what we had because it still gets the accumulator and the current params. And now inside of this, we'll take the accumulator, and to it we will add the length of the current item because the items are going to be strings. So now let's go ahead and create a list of names, and inside this list I'll put my name, and then let's put Sarah Ito. And let's put, I don't know if you've heard this song, but there's a long name involved. It's John Jacob Jingleheimer Schmidt. So there's a lot of characters there now, and that's essentially what we were going for. If you haven't heard that song, look it up. Okay, now we've got character count being defined. And so what we're going to do is add up all of the characters in all of the items together and get a total. And we can use reduce for that. So we'll say reduce, and here we'll pass in our lambda. So I'll Control X and put it right in here as the first argument. And now as the second argument, I'm going to pass in names. And remember, we do have that optional starting value. And here, it's not optional because we're using strings, but we want to tell reduce, hey, we're going to be using numbers. If not, it would view this as a string that was trying to add a number 2, and we would get a type error back. So we put in the starting value of 0 as well, and then we'll have our character count value. So let's find out how many characters in total if we added all of the characters up from all 3 names that we have. So now we can run our reduce, and we get 47. So that is a little more complicated example there to show a good use of reduce, even though it's still kind of a simple example here in learning. You'll learn more about reduce as you continue to learn more about programming. But now today we have covered lambda functions, function expressions, and higher order functions. Remember, it's a higher order function if it receives a function as an argument or if it returns a function. Remember to keep striving for progress over perfection, and a little progress every day will go a very long way. Please give this video a like if it's helped you, and thank you for watching and subscribing. You're helping my channel grow. Have a great day, and let's write more code together very soon.